Hi guys, so this is going to be an introduction to our new unit, and we're going to be talking about transformations, okay? Before we talk about transformations and specifically what they are, what type of rules we're going to have, we're actually going to do a little quick review of Algebra 1, because I'm going to be able to show you guys a connection between some algebra skills and how we can tie that into geometry, okay? So reading from the top, it says, in algebra, you studied functions extensively, and during that time, you learned how to solve for variables using function notation. Let me show you a few examples to remind you. So for number one, it says, what is the value of the function f of x equals 2x squared plus x when x is equal to 4? So all that means is that I'm going to take that function f of x, and wherever I see an x, I'm going to substitute in a 4. Now the notation I'm going to use, instead of f of x, I'm going to say, okay, my function, when it's evaluated at 4, equals, again, I'm just going to go ahead and substitute that 4 in for the x there, so 2 times 4 squared plus 4. Now using order of operations, I want to square that 4 first, so 4 squared is 16. So 2 times 16 plus 4 is going to give me 32 plus 4, which is 36. So how I'm going to write my final answer is the function evaluated at 4, or f of 4, is equal to 36, okay? Now, number two, what is the value of the function f of x is equal to negative 5x plus 1 when x is equal to 11? So again, same notation here. I'm going to evaluate my function at 11. So anywhere I see an x, I'm going to replace it with the number 11. So negative 5 times 11 plus 1. That'll give me a negative 55 plus 1, which is equal to a negative 54. So again, my function evaluated at 11 is equal to a negative 54, okay? Last but not least, what is the value of the function f of x is equal to negative 2/5 x when x is equal to 5? So again, all I'm going to do is find my function evaluated at 5 and substitute in the 5 for my x there, so negative 2/5. Now I'm going to write 5 over 1 just to kind of keep it in terms of like terms for fractions here, okay? Now anytime you're multiplying fractions, if you have a common term or common number in the numerator and denominator, you can go ahead and just cancel those out. Okay, and what you're going to be left with is negative 2 divided by 1, or just negative 2. So my function evaluated at 5 is equal to negative 2. Okay? Now I fill in the blank section here. It says, in all these examples, we were given the x value. Right? They gave us the x value when x is equal to 4, when x is equal to 11, when x is equal to 5. Okay? And we know our x value is also referred to as the input. Right? You input in a number, and then you get out the output. Okay, so we were given the x value and then asked to solve for the y value, or to solve for the output. Solve for the y value, or it says the value of the function, okay, or the output. In the next examples, we will be given the y value, the value of the function, and then asked to work backwards. So now it's going to be a little bit different. They're going to give us the output, and we want to work backwards and find the input to determine the x value that would have produced that result. Look closely at these examples. So now they're giving us the function. They're saying, what is the value of x? I'm going to be solving for x when the function of x equals 8x minus 5 and the function of x equals negative 29. So if I go ahead and rewrite this, right, the function of x is equal to 8x minus 5. Okay, notice they're not giving me the x value. They're saying the function of x is equal to negative 29. So I'm going to go ahead and substitute the negative 29 and for that f of x there. So I can rewrite it as negative 29 equals 8x minus 5. I can go ahead and solve my two-step equation. Add 5 to both sides. Negative 24 is equal to 8x. Divide out the 8. And now I get x is equal to negative 3. So now you're actually going to be solving for the input, right, or that x value. Okay? Number 5, what is the value of x when f of x is equal to x cubed minus 14 and f of x is equal to 13? So again, rewriting my function here, I have f of x is equal to x cubed minus 14, and they're telling me the value of the output, or that function f of x, is equal to 13. So I'm going to go ahead and replace f of x here with the number 13. So 13 equals x cubed minus 14. I want to isolate x cubed here by adding 14 to both sides. So I get 27 is equal to x cubed. Now you're trying to think what number times itself 3 times, right? Because that's what raising to the power of 3 means, equals 27. Well, let's test out some numbers. Let's start with 1. What's 1 times 1 times 1? Well, 1 times 1 is 1, times another 1 is still 1. All right, so not 1. How about 2? Well, 2 times 2, that's 8, times another 2 is 16. Well, that's not 27, so let's try 3. 3 times 3 is 9. 9 times another 3 is 27. All right, so that means my x value here is going to be equal to 3. Okay? Now my last one, what is the value of x when f of x is equal to 1x divided by 3 and f of x is equal to negative 15? So again, rewriting my function, f of x is equal to 1x divided by 3, and they're telling me the output f of x is equal to negative 15. So I'm going to go replace that output value with negative 15. So negative 15 equals 1x divided by 3. Now again, I want to get the 1x isolated. So the opposite of dividing by 3 would be multiplying both sides by 3. 3 times a negative 15 is a negative 45. And that's what my x value is equal to. Okay, so what I just spent some time doing, guys, is going over basic function notation, right? Putting an input value into a function, solving for the output. Putting an output value into the function, solving for the input. Now we're going to actually use that exact same skill, but now we're going to tie it to a geometry concept, okay? So here's our connection to geometry. Okay, it says in geometry, we have a similar input slash output process when we determine how shapes are altered or moved. So now we're going to be talking about how we can move shapes, like how I can move a triangle or a square or a circle, how I can move them, right, using special transformation rules. And those transformation rules are going to be using the same skill that you guys just did on the worksheet above, okay? So if you guys see, it says input, output, right? So those are my algebra terms there, input, output. But now the geometry terms we're going to be using, instead of input, you're going to be using pre-image. And instead of output, we're going to be talking about image, okay? And what you see in between those words, that capital T and then X comma Y, that's just going to be naming our rule. Doesn't matter what that letter is. So for here, this would be my rule T, right? It could be S, it could be V, it could be W, it could be B, whatever it is. They're just using T for this example. And they're saying that your transformation rule is X plus 3 and Y minus 6, okay? So that English translation just means, hey, our coordinate rule T is going to map or move all points X, Y to X plus 3, Y minus 6. You're saying, Miss, what do you mean X plus 3, Y minus 6? What do you mean move those points by that rule? So let's talk about it. Rule T is going to move or map. So when I say map, that means kind of move. They're interchangeable words there. All points X, Y by adding 3 to the X value, where X is X plus 3. So adding 3 to the X value of each point and subtracting 6 from each Y value each point, right? Y minus 6 means I'm subtracting 6 from each Y value, okay? So to help clarify the difference between a pre-image and image, the pre-image is going to be the shape before we move it, and then the image is going to be the shape after we move it, okay? So to help clarify the difference between a pre-image and image, we're going to use special notation. That's your next fill in the blank. Okay? If the pre-image is point A, then the image is going to be A prime. And A prime is the exact same letter, but now you're going to put a little apostrophe there. That little apostrophe represents the prime, so to speak. Okay, so A prime would represent my image. The pre-image is just regular old capital A there. Okay, the prime notation tells us that it is an image. Okay, all right. If you guys go to the next page, you flip to the back. Okay, so now we're going to actually use those skills again, but we're going to do it using our translation rules. So saying, given the coordinate rule capital M, right, so M is my coordinate rule, x, y, 3x minus 1 comma 5y, determine the image of 3 comma 2. So now I'm going to be looking for the image, right? The image is kind of like the output almost in terms of algebra. So they're telling me that my pre-image, point A, is 3 comma 2, right? I'm going to solve for A prime, because A prime is my image. So I'm going to take that pre-image point 3, 2, I'm going to substitute the x coordinate point 3, and for x here, and I'm going to substitute the y coordinate point 2, and for y here. So I'm going to have 3 times 3 minus 1, that's going to be my new x point, And then I'm going to have 5 times 2, my new y point. So let's see, 3 times 3 is 9. 9 minus 1 is 8. And then 5 times 2 is 10. So that means A prime is going to be 8, 10. So all I did was take the original point, the pre-image, substitute the 3 in for the x, and then the 2 in for the y. Again, I just evaluated, just like how you guys evaluated on the front side of your notes. Okay? Now 8, given coordinate rule w, okay, x comma y equals, or is mapped to x minus 4 comma negative 3y, determine the image of b, which is negative 1, negative 2. So again, my pre-image b is negative 1, negative 2, and I'm solving for b prime, which is the image. So I'm going to take negative 1, go ahead and substitute it in for x, take negative 2, go ahead and substitute it in for the y. So what that's going to look like is negative 1 minus 4, comma, negative 3 times a negative 2. So negative 1 minus 4 is a negative 5. Negative 3 times a negative 2 is a positive 6. So that means b prime, or my image point, is going to be negative 5, comma, 6. All right. So now the last piece here, guys, both of these examples, again, we were provided with the pre-image, or the x value, right, or the input. So just like how you guys did on the front, right, these examples, we were given the input values and we solved for the output. On these ones, we were given the pre-image and we're solving for the image. So hopefully you guys can see that connection there, okay? Now, or sorry, let me finish the fill in the blanks here. So both these examples provided the pre-image, the input values, and then asked you to solve for the image or the output, okay? We can now work backwards using this process, or we can work backwards through this process. Let us look at 2 where we know the image or we know the output, right? And we're going to work backwards through the coordinate rule to solve for the pre-image or the input. So again, how we kind of work backwards here, right? We plugged in the number for the output. Now they're giving us the image or the output. We're going to plug it in and solve for the input or the pre-image, okay? So my coordinate rule t is 5x plus 3 comma 7y, and I'm going to determine the pre-image of c prime, and c prime is 13, negative 7. So again, I'm solving for c now, the pre-image, if my image c prime is 13 comma negative 7. So what you guys are trying to think is, okay, 5 times what number plus 3 is going to equal that 13, and then 7 times what number is going to equal the negative 7, okay? And we can just set up a 2-step equation or 1-step equation to solve for those. So I'm going to match up my x-coordinate rule with my x-coordinate here. So 5x plus 3 is equal to 13, and then match up my y-coordinate rule with my y-coordinate. So 7y is equal to negative 7, and we're just going to solve. So I'd solve my 2-step equation here, subtract 3, 5x is equal to 10, so x is equal to 2. So my x point for my pre-image is 2. Now solving for y, I divide out the 7, and y is equal to negative 1. So that means my y-coordinate point is going to be negative 1. So the pre-image point that I just worked backwards to solve for is going to be c, which is 2 comma negative 1, okay? And lastly, number 10 here. So again, given the coordinate rule g, okay, x, y, it maps x plus 7 and then 2y divided by 3. Determine the pre-image of d prime, which is negative 4, 4. So again, I'm trying to solve for d, my pre-image. My image, d prime, they're telling us is negative 4 comma 4. So I want to think, what number plus 7 gives me negative 4? And then 2 times what number divided by 3 gives me a positive 4. So yeah, I'm just going to set up equations here. So I'm going to match up my x plus 7 to the negative 4. So x plus 7 is equal to negative 4. And then my y-coordinate to my y rule. So 2y divided by 3 is equal to 4. We're just going to solve. So I'll subtract 7 here, minus 7 minus 7. X is equal to negative 11. So that'll be my x-coordinate for d. Okay, and then to isolate my y here, let's first get rid of the 3 in the denominator. So I'll multiply by 3 on both sides. I get 2y is equal to 4 times 3, which is 12. Divide out the 2, and I get y is equal to 6. So my y-coordinate is going to be 6. So d would be negative 11 comma 6. Again, I'm going to have you guys stop right here with the notes. You don't have to worry about the input-output section on the notes here.